Ellipse art and math. So today we're going to create some string art using a really basic idea of the set of all points that are equidistant from 2 points, A and C. It's going to be an ellipse, so it's that distance. So if I take the distance from some point out here, we call the point P between A and C, and we take the distance, add it together, and that distance is always constant. Another way to think about this is I'm going to create a radius or a somewhat of a radius connecting a point on the circle D with C, and I'm going to take the perpendicular bisector. And then as I drag the perpendicular bisector around, what I'm going to end up with is what looks like string art, and it really is kind of a string art activity here. And if I go slow enough, you'll start to see the outline of an ellipse inside there. So now the question is, how are these points related, and how can I create the equation of this ellipse and then come back and do that same motion and actually outline the ellipse that's being created here. Alright, so I'm going to zoom out a little bit, clear all that out. So first thing I've got to find out is figure out where the center is between these two. So I want to find the coordinates of point A, so let me make sure it's all cleared out. Point A is selected. I want to find the measurement. I want the coordinates of A. Move those out of the way. I want to do the same thing with the coordinates of C. I've got too much selected here, so let's coordinates of C. Measurement coordinates. So those two are going to help me figure out that my center is halfway between these two. I could connect them and find the midpoint and then find the coordinates of the midpoint. But I can just tell right now that it's going to be at -3, 0. So right now I do know some things. I know that I'm going to create a sticky note. The center is at -3, 0. Next thing I want to find out is I want to find out the distances that I'm going in the x direction and in the y direction. So what I want to do is I want to find the length of that CD segment. I want to find the length of that, so that measurement. I'm going to drag that over here. It's called B currently. Grab my selection tool. I'm going to drag point D back over to a place where it's at its absolute minimum. That's happening at 2, and that's going to be in line. So I know the distance from the center to the end of this ellipse is going to be, it goes to 6, so it'll go one more. That's going to be to 7. So that means that that variable, the x direction, in the x direction I'm going 4. In the x direction that's going 4. Now I want to know how high up and down I go. So the highest I'm going to go is up here somewhere, and that's where it's going to be perpendicular. So what I'm going to do is I'm going to create a perpendicular. I'm going to select CD, construct a perpendicular. I got to select the point D, construct perpendicular. There's my nice little perpendicular mark. So what I want to find out is at what point is that going to be at its absolute minimum there. So I'm looking at it when it's exactly, first time it's turning to 90 degrees. It looks like it's 5.21, 5.23. So in the y direction, I'm going 5.23. It's 5.23 divided by 2 because I'm looking at the total distance of the blue, but I only want half of that. So right now I've got all the information I need. I should be able to create my equation. So I'm selecting an equation. I know the equation is x minus -3, which is +3, quantity squared. So I'm going to go ahead and square that on the outside. In the denominator, whoops, in the denominator I will have 4 squared plus y minus 0. I will put in y minus 0 raised to the second. Divide that by, I said it's 5.23 divided by 2 quantity squared. I want to square that on the outside, raised to the second. I'm going to make that equal to 1. So here's my equation. It's in here. Let's move that equation out of the way there a little bit. Grab my selection tool. Let's put that equation a little bit out of the way. As much as I can. I'll zoom out some more. Because now what I want to do is I want to connect the two ideas. So let's see, if I drag this around, you'll notice that it will trace out the blue ellipse that I have perfectly. So now there you see the connection between the string art and the actual equation. Another one you can do is if you move point C outside the circle, so all I will do here is move point C outside the circle, everything else will stay the same. Now when I drag point D around the circle, you're going to see a different shape when I zoom out. Let's zoom out to clear everything out. I'm going to take and drag. The only difference between this and now the new shape I'm getting now is now I have a hyperbola. So now the question becomes, what's the equation of the hyperbola? I'll let you try to figure that one out, but hope you had fun.